So the first thing that we're going to talk about today is some what I'm calling basic concepts in research design. So for a lot of you may have come to this class right out of REF 601, the Intro to Research Design class, and so you did not have that class before this. And so this will either feel like I just learned this last semester, or feel like I did not learn this ever. And so either way, we'll get there, right? All right. So first, we'll talk about levels of measurement. So there are 4 levels of measurement. So these are the levels at which data might be measured. We have nominal, ordinal, interval, and ratio. Talk about it one at a time here. So nominal level data are literally categorical data that have no numeric value whatsoever. So we're just naming the category. So think about gender, right? We might categorize people as men and women. There's no numeric value to that whatsoever. Just saying, these people are men, these people are women. We might want to do something with that categorization, compare men to women, for example. But there's no numeric value to that categorization whatsoever. We can't rank them. We can't prescribe a quantity to that. It's just what they are. Right? Same thing for something like ethnicity. Right? The U.S. Census uses 6 ethnicity categories. And we could number them like 1, 2, 3, 4, 5, 6, but there wouldn't be a real numeric value to that. It would just be convenient the way we would number them. Yes/no questions, right, would be sort of nominal because there's no numeric value to whether you said yes or no. It's just what you said. When we talk about ordinal level data, it's still categorical, placing you in some group, only now that group has some meaningful numeric value. All right, so take the example of college classification. There's 4 groups, right? Freshman, sophomore, junior, senior. But those groups have some meaningful numeric value that we can rank order those 4 groups. You could say freshman first, sophomore second, junior third, senior fourth. In fact, people will hopefully progress through those 4 ranks, right? One after the other. Okay. So we can meaningfully order those. Another example of ordinal data would be like if we say order finishing in a race or something like that. You could be first, you could be third, you could be 278th. You couldn't be first and 278th. You one or the other. You couldn't be a freshman and a senior. Right? So that's the other thing about categorical data is you're going to be one or the other. Right? We're going to place you in one category or the other. But with ordinal level data, we can rank order them. Place a meaningful numeric value to it. And it's an ordered value. So 1 is better than 3, or 1 is higher than 3, or whatever. Okay. When we get to interval level data, now we're talking about quantity. It's not a category. It's not this sort of quality about something. Now it's quantity. It's like how much. A lot of scales that we use are on interval level measurement because you think about, you're familiar with like Likert type data. It's often like 1 to 5, 1 to 7, 1 to 9. It's like strongly disagree to strongly agree. Well, so if you think about, we take the aggregate of a lot of people providing that kind of data, and you get this like kind of score that's like 8.63 depression for this group, right? Well, what's 8.63? It's a quantity. It's interval level data. Well, so then what's the difference between interval and ratio? Well, so there are several ways we can answer that question, and several meaningful ways we can answer that question. One of the ways we can answer that question is to talk about the presence of a true and absolute zero. In other words, a zero that's real. That means there's nothing. Like, for example, height doesn't have a real zero. We talk about 0 inches tall. What that really means is there's not a thing, right? something weighs nothing, that means it doesn't exist, right? Not as a physical object anyway. Whereas if we talk about like distance traveled, you could go 0 feet. You all have traveled 0 feet since class began. And it's meaningful. It means you didn't go anywhere. Right? Whereas if you went 3 miles, that's a pretty good sprint. Okay. Percentages are usually ratio. Not usually. Percentages are ratio. Data. Let's talk about some examples. So like a GPA, right? So GPA is on this 0 to 4 scale. Okay. Do you think it's what kind of level of measurement do you think a GPA is on?
No. Well, it could be ratio.
Ratio. So why would you say ratio?
Okay, you can have 0 GPA, although not for very long when you're going to be around.
So is that 0 like a real absolute 0?
As in there is nothing there. Because it doesn't represent anything.
Right. It represents the absence of grades or something.
It represents an absence of acquired knowledge.
Does it?
Well, sufficient amount of acquired
I mean, it's the lowest GPA we can get, right? Is 0. But there are certainly lower grades that you can get. Just think about 0 GPA means anything from 59.999 all the way to 0 for your class grade. Whether you got zeros in all your classes or you got 59s in all your classes, your GPA is 0. Is that an absolute 0? It's the absence of knowledge. It's just not very good knowledge, not very much effort. It's not the absence. Now, there's some qualitative designation that goes with the 0 GPA. It's like far below expectations or something like that. Is it an absence? Is it a real absolute 0? There's nothing. No. It's like absolute 0 is like no heat, right? Is this like no learning? I don't know that it is. I'll probably say interval for GPA. And then we have these meaningful units, right? These interval units between like 0 and 1, 1 and 2. It's the same interval all the way up. I'll probably say interval. What about like your class grade? So your class grade in here could at the end of the class be A, A minus, B plus, B, B minus, C plus, C, C minus, D plus, D, or F, right? These are the available options. What kind of data are that? Is that? Yeah. It's a category, right? We'll put you in a category, and we can rank that pretty meaningfully. Yeah. I think so. Okay, so what about student retention? So like you hear a lot about this at colleges, right? Like what percentage of the students are you retaining? And we hear about like, I think it's like 76% at USM get retained. Don't quote me on that, might not be right, but I think it's in that range, 76, 78, something like that. So like what, like let's say it's 76%, right? Well, what's 76% be? Is that ordinal, nominal, ratio? Ratio? Why ratio?
You said it was a percentage.
Mm-hmm. Right, percentages are going to be ratio, absolutely. Okay, gender. Nominal, great. Ethnicity? Nominal, right. Height. Interval. There's no true 0, and a centimeter is the same no matter how tall you are, an inch is the same no matter how tall. Yep, absolutely. Weight. Yeah, it's interval on the same exact logic, right? Class size, number of people enrolled in the class.
Ratio, because it has a true 0. It could be 0 people
Could be 0.
0 than you don't in class.
Uh,
On that interval.
so, right, so it might be an issue of perspective, right? Because I think if you're an administrator, you could think of 0 as meaning there's something wrong with the class, or we have to make a decision about this class next summer, or whatever. But I think for a student or an instructor, you're probably thinking 0 means there's no class. It doesn't exist, right? So it might be an issue of perspective what you would think about that. Certainly, the unit of measure stays the same no matter how many students it is. One student all the time. It's the same amount of student gets added every time you add one. So I don't know, maybe interval, maybe ratio. I probably lean toward interval, but you can certainly make the argument for ratio, I think so. And what about instructor ratings? So here I'm thinking about, like, so at the end of the semester you fill out these rating scales, right? It's like strongly disagree to strongly agree on this number of characteristics. And then I'll get back this number that's like 3.83. Right? So what do you think? Interval? It's useful to know that people will argue at the level of the person filling out the survey that might be ordinal because you're choosing a category. And the categories are ranked. So people will make the argument at the level of the individual filling it out, it might be ordinal. But certainly by the time it reaches the instructor who's getting 3.83, that certainly feels interval. Yeah. Okay. So let's talk also about some key research terms that hopefully will at least some feel familiar. So what's an independent variable?
It can stand alone regardless of what it's dependent upon.
Okay.
It's the thing you change, you manipulate.
Yeah. So independent variable is going to be the thing that we change. So in some way we're going to manipulate the independent variable. So examples the classic example is going to be like a drug that we administer in varying doses to different people. And maybe we're going to see if they have different symptoms based on that, right? In educational research, we might put people in 3 different types of instruction and see if they learn differently based on the type of instruction. Right? We work a lot in educational and behavioral research with what we call quasi-independent variables. And so a quasi-independent variable is going to be a variable we're treating as if it was manipulated, but we can't actually manipulate it. So think about the number of studies we do with gender, right? Or ethnicity, or the state that somebody lives in, or something like that. Things you can't manipulate, you just can't. And so we say, well, what we're going to do is observe your current status as being a man or woman, or living in Mississippi versus Alabama versus Kentucky, whatever. And what is the outcome, is the outcome different based on being man or woman versus living in Alabama versus Alaska, whatever it is. And we treat it as if it was independent, even though we didn't manipulate it. Just basically pretend. It's a quasi-independent variable. But a true independent variable is going to be manipulated by the researcher, for sure. And then the dependent variable is what?
It doesn't change.
Well, we don't change it.
But we don't.
It's the result of what you've changed.
Yeah. So we're expecting it to change based on the independent variable, right? So like if we put people in 3 different instructional conditions, expecting that their math learning will be different, then their math learning is the dependent variable. In that case, we would say instructional style is the independent, and math achievement is the dependent variable. It's the outcome. Absolutely. What about a confounding variable?
Kind of like the mediator variable.
Can be, yeah. So here with the confounding variable, it's a variable that confounds our results, so that probably doesn't help. But it's a variable that is going to have some influence on the outcome, but is not what we're interested in. right? So in other words, it can come in and sort of muddy up the picture a little bit, right? So you've got instructional style as your independent and math achievement as your dependent, right? Well, maybe gender plays a role on math achievement, or maybe the setting plays a role on math achievement. Maybe interest level plays a role in math achievement, right? So now we've got this whole set of other stuff going on that is going to influence the outcome, but it is not what you're studying, right? So if we fail to account for all that stuff, right, we're going to have an unclear connection between the independent and dependent variable. So what we want to do is we want to think about ahead of time all of the potential confounding variables, measure them, and then account for their influence. So if we can account for their influence, we can sort of pull that out and get a clearer picture of the role of the relationship between independent and dependent variable. Right. Say, what's the relationship between instructional style and math achievement after we account for the role of setting? Right, that some people were in a traditional classroom and some people were in a blended classroom or whatever it is. Right? So we want to think about those things ahead of time so that we can measure them. Because what happens all too often is people realize after the fact, like, oh, one of the teachers was a woman and one of the teachers was a man, and I forgot to think about that, you know, and mix it up a little bit and see if that would make a difference. Right? Okay. What about the operational definition? Familiar? Okay. So an operational definition is, so we have independent variable, we have dependent variable, we have confounding variables. We have to, though, define what we mean when we say math achievement, for example. Right? So math achievement can mean a lot of things. First of all, which math and what kind of achievement? Right? So math means a lot of things to a lot of people. Let's bring in 10 math experts and ask them what math is. Right? You're not going to get probably 2 similar answers out of those 10 people. Okay? So first of all, are we talking about algebra? Are we talking about geometry? Are we talking about trigonometry? Are we talking about calculus? What are we talking about? Those are not the same thing, and someone might have high achievement in geometry and low achievement in calculus, right? It's not the same thing. And someone might have high achievement in both of those and low achievement in statistics, right? Not the same thing. Granted, they both use a calculator, but they're not similar beyond that. Well, they're not very similar beyond that. Okay, so the other thing is, like, what do we mean by achievement? Are we talking about the grade in the class? Are we talking about the grade on one of the state standardized tests? Are we going to use one of the new Common Core tests? Are we going to use like an Iowa test of basic skills? What kind of assessment are we getting? Like, how are we defining achievement? Right. Then you take into account something like our independent variable. We're saying we've got instructional styles. So like, so let's say that our instructional styles were like traditional versus experiential versus problem-based, right? Well, what did you mean when you said traditional, right? For some people, traditional means like, you know, the roll-up projector film where the person's just sitting there, you know, drawing out the triangles on the thing, right? Well, is that what you meant, or did you just mean that it was more lecture-based? Or did you just mean that it wasn't experiential or problem-based? Anything other than that was what you meant, right? So we have to define that so that we can, first of all, repeat your experiment. And second of all, let's say somebody decides they want to do the thing that you're suggesting. Right? 'Cause let's say you find out that experiential-based learning is really superior in your study. Well, I might decide I want to do experiential-based learning then based on reading your study. I got to be able to figure out what it is that you did and go do it in my classroom. So we need a really specific and actionable definition of what you mean. Right? I think about something like, there's a variable that I do research with called self-efficacy, basically your belief in your ability to accomplish a given task, right? And it's been defined probably 30, 40 different ways. So when people say like self-efficacy in a study, you immediately look for like, okay, so who did they cite as their definition? Because it makes a huge difference in what they mean and how they're going to proceed from there. And if they don't have anything, they're just saying like, I don't know, just sort of like, well, I don't know what to do. I don't know what you're talking about. Right? So we have to have really clear operational definitions. Okay, and I want to talk a little bit about experimental versus correlational research. And the first thing I want to say is people get confused about correlational research because they think that means you use the analytic technique of correlation, and that is not true. You could, but you could also use correlation in experimental research, right? So the difference between experimental and correlational research is whether we have a true, randomly assigned independent variable. Right. So in experimental research, we're going to have a true independent variable with conditions to which we've randomly assigned participants. Whereas in correlational research, we're using intact groups and studying the associations between, for example, group membership and some dependent variable, right? So it's some sort of quasi-independent variable. We also might just study the associations between two continuous variables or something like that. And so in experimental research, we're going to use random assignment. Okay? And so what random assignment means is that every person in the sample has an equal probability of ending up in any of the experimental conditions. So we've got these three different instructional styles. We can't assign people to that based on which class they sign up for, or now it's a quasi-experimental study. Right? What we'd have to do is have 150 people sign up, and then pull names randomly and assign them to one of the three conditions. Right? Pull them out of a hat. The first one you pull out of a hat is going to wind up in the first one. The second one you pull out of a hat. Right? Because if you just have the first 50 people to sign up, go to the first one. Right? Well, so now what we have is people who sign up early are in traditional classes. People who sign up late are in problem-based classes. Right? So you've got biased sample at that point. See, because we don't really know that it was traditional learning that made a difference. It could be it's early risers make the difference versus procrastinators learn more poorly, right? We don't really know what made the difference. Whereas what random assignment does is it takes all that stuff, like whether you are an early adopter or a procrastinator, whether you are a person who signs up for face-to-face versus online, whatever it is, all of this other stuff about you, your personality, characteristics, all of it, gets sort of randomized out into the conditions so that the only difference between the three conditions is whatever we do differently between the three conditions. In this case, the type of instruction. Which means if there's a difference in the outcomes, it's because of what we did. It's the only thing that's different between the groups is what we did. So if there's a difference in outcome, it has to be because of what we did. This is the beauty of random assignment. It's why we like random assignment. Now, that doesn't mean we're still not going to do analyses based on things like gender or personality or whatever. But we can be pretty confident that if there's a difference between those groups, it's because of what we did. When we can't randomly assign, we can't be that confident about it. So it really pulls back the kind of inference that we can make. And now we're saying things like, well, there's an association between instructional type and achievement outcomes. We're never going to be able to say something about causation ever in a correlational study. Whereas you might be able to say that in an experimental study if you meet some other conditions, which we'll talk about later in class. So random assignment is ideal, but we often cannot do it in in educational and behavioral research because of the kind of variables that we're working with. Right? There's just so many variables that it's either impossible or unethical to randomly assign. Okay. And then we'll talk about reliability and validity for a little bit. And so just, I guess in a word, we would probably say that reliability is consistency and validity is accuracy, if we had to break them down to one-word definitions. Which I don't know that I had to, but I did. Okay. And so here we're talking about the ways that we measure our independent and dependent variables. We want to be consistent and accurate, right? Reliable and valid. Okay, so I'll illustrate this with a pretty common, I guess, illustration that's used, which is the target, right? So you think about like you're an archery person, an archer, I guess, and you're going to fire some arrows at a target. You'd like to hit the center of the target every time. So like here we might say that the center of the target is like algebraic achievement, right? And so if we could get that every time with like all 7 test questions that we're going to write, then that would mean that we had a test that was always measuring algebraic achievement. Right? So like say that you have some sort of item cluster that looks like this, right? Well, you have 7 items that are measuring the same thing very consistently, but not accurately. There's no accuracy, right? I don't know what you're measuring. Maybe this is like trigonometry or something. I don't know. It's like in the math domain. It's not algebra, though. Right? Okay. This is reliable, but not valid. We could have this situation where, like, I don't know, you're like around the center of the target. You have like one item that's really on target, but you're not really hitting the target, not consistently. So this points out for us the fact that, like, without reliability, you cannot have validity. It's impossible. No reliability, no validity. Can't happen. Because if you're not hitting the same target every time, you can't really say you hit the target, right? You're not consistently hitting the target, you're not hitting the target. That's how that works. Okay. Right. And here I think this one's just like a lot worse, right? Yeah. Okay. So then the ideal would be we have all of our items measuring the same construct, in this case, math achievement, doing so consistently, a reliable and valid measure. Okay, so like how do people get at validity? And I just want to give a really rough overview of this. It's things like content validity. So we might think about the items. Like, so if we're talking about algebraic achievement, for example, we might look at, so what are the content areas within algebra, right? So like, I don't know algebra, but I'm sure there's like 5, 6 different major content areas. We might look at like the competencies, and state standards for algebra, and make sure that we've, have a question addressing each one of those, so that we can make sure we're measuring all the relevant content. We might measure our test against other known tests of algebraic achievement, and make sure that it's correlated well with those. Like, right, if they're a good test of algebraic achievement, our test should also correlate with those, right? Just makes sense. Right. Construct validity is sort of a combination of other types of validity evidence. Also with criterion validity, say algebraic achievement should predict your ability to do well in an engineering class, right? Well, so if our test is supposed to measure algebraic achievement, it should also predict your ability to do well in a beginning level engineering class, right? So my test is predictive validity as well. And then face validity just has to do with whether it looks like an algebra test, and people question whether that's important, which is why it has a question mark here. When we talk about reliability, I find that the one that people are the most familiar with is test-retest. If I give the same test a second time, will I get the same results? It's not one that people actually measure very frequently, and for a couple of reasons. One of those is practical, right? We have to find the same people and give them the same test a second time. So that's always a problem. But the other thing about test-retest is that there's so many constructs that we wouldn't expect to get the same result if we gave the same test to a person a second time, right? So, for example, think about anxiety, right? Like if you were to take an anxiety scale at the beginning of this class and then Saturday at 1 o'clock, would we expect to have the same results? No, I mean, hopefully not, right? Like, hopefully those are not similar situations in terms of anxiety production. I don't know what you're doing on Saturday, but hopefully it's better than statistics. And there's a lot of constructs that are like that. You think about depression. Hopefully it changes over time. Hopefully you would be reliably depressed across your whole life. So there are some, and it's like I studied procrastination in part, and like one of the things that we know about procrastination is it's situation dependent, right? So depending on what class you're in, you're going to procrastinate at different levels. So it could be the test this semester, it won't be the same as next semester, right? So there's a lot of constructs that we wouldn't expect to have test-retest reliability, and it would be troubling if they did. And there are some, like you think about personality. Let's should have high test-retest. So anyway, so I just said about test-retest, like we wouldn't always want to have high test-retest reliability to get the same score if we gave the same test twice. By and large, what people look at for reliability is what we call internal consistency reliability. And almost always, I say almost always, I would say 95% of the time, people are using coefficient alpha, otherwise known as Cronbach's alpha. You may have heard of it referred to that way. You usually see it referred to that way, actually, but there's good reasons just to say coefficient alpha. So internal consistency is the idea that if you've got, say, 10 test items, right, and they're all 10 supposed to be measuring, say, interest in mathematics, right? Well, those 10 items ought to be scoring pretty similarly, right? They're all measuring the same thing. For the same person, the scores should be pretty similar. Does that make sense? It's the same construct, same person. So their underlying level of interest, right, it's going to be like, I don't know, like a 7 or something. So all those items ought to be pretty close to a 7 if they're really measuring test anxiety or something, right? So this type of measure, coefficient alpha, is essentially a measure of whether or not all those items are sort of clustering together, measuring the same thing, right? Are they consistent in their scores? So that's what we call internal consistency. Are the items consistent with one another? There are other ways of getting it. Like split halves, like you cut the test in half, correlate the two halves. Okay. What I have for us to do now is a practice exercise. This is small groups. We'll see how many groups we can form here. But maybe 2 groups or something. And so what we'll do with this is there's, I'll let you guys form the groups as you want to. And with each scenario, it's asking you to identify independent variables, dependent variables, confounding variables, levels of measurement, and the type of study that's being done. And so then when you get in your groups, I'll assign 2 of them to each of the groups, and we'll come back together and talk about them. Okay, so let's talk about sampling methods. And so specifically what I mean is ways that we sample from a population of potential participants in order to have this group of people participating in a study. Okay. So the ideal would be what we call random sampling. So with random sampling, what that would mean is every person in the population has an equal probability of ending up in the sample. Right, so you could think of like you're going to have a sample of 200 for your study, and your study is about, college transfer students, right? So like maybe there's, I don't actually know, but maybe there's like 2 million college transfer students in a given year. So that would mean that all 2 million of those people have an equal probability of ending up in your sample of 200, right? Not the, I don't know, whatever, 2,000 that we have on campus here this year. The 2 million in the U.S. population all have an equal probability of ending up in your sample. Okay. Well, so that's an important feature because all of the analyses that we'll learn in this class, except for the unit late in the semester on non-parametric statistics, fall under what we call the general linear model. And one of the assumptions of the general linear model is that we have randomly sampled from the population. The reason that that assumption is there is that if we're going to make these sort of generalizations from our sample to the population, the sample has to adequately represent the population. The most adequate representation of the population would be a random sample. Right. And so we want to represent the represent the population, because when we say things like, for example, taking from our example earlier in the class, we want to say like experiential learning led to better math acquisition. We want to be able to say that not just for the 30 people in this group it was better, we want to be able to say it will be better for other students, right? We're not hoping to say it was better for these people I happen to encounter. We want to be able to say it's better for students in general. Right? So if we can't say that, then really the research isn't all that meaningful. If we can't make some kind of generalization. So sampling becomes really important because sampling is how we're able to make generalizations. But it's not all that reasonable typically to think that a random sample is even possible, right? So you think about a case where we're interested in these 2 million, I made up that number, but 2 million transfer students in the US, right? So let's just look fantasy world for a minute, right? And imagine that out of those 2 million, I could actually obtain all of their contact information. Right? I mean, I can't, but let's say I could. Okay. If I could, and then I could get a random sample of them for 200, and I'm gonna now let's just say magically be able to like show up at the door and say, "Hey, I've got a survey for you." Now, what's the problem?
They may not want to do your survey.
They may not want to do the
They may
survey.
not be home.
Well, I'll wait for them. It's no problem. Right? This is fantasy world. But once they get there, they might say, "No, I don't want to do your survey." Right? And I can't make them. That's illegal. Right? We can't do any sort of coercion. Unethical. So if they say no, then we're out of luck. I'm not interested. I don't have time. Whatever. There's this whole array of reasons, right? So like your typical email survey is going to get between 5 and 8% response. In other words, 92 to 95% of all people will be like, I don't think so. Right. So, and mail surveys can get up to 10, but still, 90% of all people are like, I'm not going to take the time to do that. So, what you're left to think about is clearly, if you are 5% of the population that are willing to do a survey, that 5% is probably not that representative of the rest of the 95%, right? There's probably something unusual about those 5% of all people that see an invitation to a survey and go, of course. Sounds fun. Let's do it. Only 30 minutes of my time? Oh, okay, no problem, right? Whereas I think that most people see 30 minutes of their time and think, oh, no way, right? So we've already got a sample that doesn't really look that much like the population, just by virtue of the fact that they were willing to do an email survey, or a mail survey, or whatever kind of survey it was. Right? So random sampling is not really something that is all that possible. Okay? Although it is the ideal. Some of the common ways that people actually get their surveys. So what is convenient sampling? So convenient sampling is by far the most common way of sampling, and it's because it's convenient, as the name implies. So think about, there's this saying, and it's very, very true, that we know a whole lot about undergraduate psychology majors in their first year, and we don't know a whole lot about anybody else. It's because the people that wind up in studies are, by and large, intro to psych students. We're taking like Psych 101, or 111, or whatever it's numbered here, right? They're taking that first psychology class, and so not only are they in these classes of 300 where you think, oh, a class of 300, that sounds nice, right? I get 300 people in one day, okay, right? But also they're in a class where their instructors try to teach them about the value of research, and so will likely require them to participate in research. Their instructor also values research and is likely to let you come and do your research. Right? So there's all these factors that add up to where they are doing a lot of research. Okay. Very convenient. They're a captive audience. They're an audience that's likely to be forced to participate in research in one way or another. Not forced, but required to get some sort of research credit. Usually one of the options is to participate in studies. So a lot of studies are done that way. Another version of a convenient sample would be like you're working at a community college, right? And you say to your friends, obviously not to your own class because that is illegal and unethical, so don't do it. But like you would say to your friends' classes, can I distribute this survey in your class? Right? I say, well, yeah, sure, you're my friend, you can come to my class, right? And all of a sudden now you have this sample of the people who surround you, right? They're just the people who are around you. They were lying around, they were convenient, right? So you went and picked up these samples. It's like change on the ground, right? Very convenient. Doesn't mean it's the best sample or the most representative sample, but it's there, so go and get it. Convenient samples are the most heavily biased sample that you can possibly get. Which makes sense. You didn't get this sample for any reason other than you could. Now, all samples are biased, but convenience samples are some of the most biased samples. Purposive and snowball often go together, right? So purposive sample is like there's a particular kind of person I want, and I'm going to go out and get that kind of person. One of the ways that people go about doing that is with a snowball sample. So I always think of this example of someone I knew that wanted to do work with, and I can never think of the name of the type of person, but like they fight forest fires like by jumping out of like the helicopters and they cut down the tree. Smoke jumper. There you go. And knew like 3 people who did that, but wanted to do research with that group. Well, so what do? You go to those 3 people and you say, "Will you participate in my study?" And they say yes. And you say, "Okay." So at the end of the study, you give them a flyer, or a handful of flyers, right? You say, "Will you give these out to people that you know that do this job?" And then maybe a couple of those contact you back, and when those people contact you and participate in the study, at the end of the study, you give them flyers and you say, "Will you give these people you know that do this job? Let them know about how important this research is, blah, blah, blah," right? And so then they go out and they tell their friends, "Hey, this study's going on. Would you let people know about it?" Right? So what you have is, you may be familiar with this model. People use it to sell makeup and nutritional supplements and all sorts of stuff. So there's you, right? And you recruit 3 of your friends. They recruit 3 of their friends, who each recruit 3 of their friends. Right? It's a pyramid scheme, right? Only for research instead of sales. Right? So as long as everybody keeps recruiting down the line, you get this sample that sort of gets bigger and bigger and bigger, like a snowball going downhill. It's called a snowball sample. But I always think of it like a pyramid scheme because that's what it is. You're saying as long as everybody gets 3 of their friends, we're all good, right? So that's a snowball sample. And the deal about a snowball sample is it only works if you want people who look the same. For example, you want a whole bunch of smoke jumpers. Right? Now, if what you really need is a sample that's kind of diverse, which is usually the case, this is not a sampling method that works. Because what are they doing? They're telling 3 of their closest friends, right? So who are our closest friends? Our closest friends are very similar to us. Social psychology predicts that our closest friends are going to be very similar to us in most meaningful ways. Right? So you're going to get this huge sample of people who are all really alike in most meaningful ways. That's not what you want. You don't want a snowball sample. Sometimes that is what we want. Right? I use snowball sampling in
You're doing a purpose sample, by its very nature, the people are going to be similar.
Right.
That similarity is something that you want. You want people to jump out of their ones.
Right. Sometimes we do want people who look similar. Like, I've been doing for a couple of years a study of gay and lesbian people who attend Christian colleges. As you might imagine, you don't go hang a flyer in the union at that college, right? That doesn't work. They don't let you do that. So snowball sample works well because people know people who know people, right? But you don't hang, like say, you don't hang a flyer up or send out an email to the listserv or something, right? But you do get a remarkably undiverse sample that way. I think that the sample is 100% white at this point, which is really unfortunate. You would like to branch out from that, but without someone who knows someone that's going to start to diversify the sample, it doesn't happen. Another form of sampling that people use is representativeness sample, representative quota sampling. And so, like, you might be familiar with the idea of quota, like in selling. If you're a salesperson, you might have a quota, like you need to sell 7 extended service plans this month, right? So here, the idea is like we want a sample that is representative of the state of Mississippi, right? And so we know that Mississippi is 53% white and 48% female, right? So we're going to want a sample that's 53% white and 48% female. So we're going to set this number, so we want this certain size of sample. So we want 263 white females in the sample, white women, in the sample. So you go out and sample white women until you hit 248, right? Once you hit 248, you're done. No more white women will be admitted. Somebody could come to you, like, knock on your door. Nope, sorry, you're done. Right? So you're purposefully sampling this one group until you hit the quota. Then we're going to purposefully sample the next group until we hit the quota. Right, so we've got a quota for each subgroup that we're interested in. Usually it's by ethnicity and gender. And then when we hit the quota, we're done, and that way we can say at the end of this, we've got this 2,000 person sample or 1,000 or 5,000 or whatever that is very purposefully selected so that it is representative of the population. Now that's still a biased sample, right? Because I went out hunting for people to fill the quota. Like, oh, I need one more Filipino person living in southern Mississippi. What am I going to do, right? Let's go find them, you know? So we're like hunting down people to fill the quota. So it's not random in any sense, right? Very purposive, yet at the end of the day, it winds up looking very representative. All right. And so the problem with all of these methods is that they're not random, meaning they are biased. So I've said that you're not ever going to have a random sample, which means you're always going to have a biased sample. The problem with a biased sample is that the further away from a random sample that we get, the less we're going to be able to trust those data to reflect any underlying phenomena in the population. In other words, we want to be able to generalize our results to the population. The more biased the sample, the less able we are to do that. So we want to minimize bias as much as possible in our sampling so that we can make the broadest generalization possible from our results. So some of the biases that we run into are things like self-selection bias. We've talked about this a little bit. The issue that people who choose to participate in your study will do so for particular reasons, whether that's general cheerful helpfulness, you know, just the kind of person who chooses to participate in the study, and that kind of person is unusual in that they are the kind of person that chooses to participate in studies. Or it could be that like they see your flyer, and your flyer is about a certain topic, and they go, ooh, that's a topic I want to do a study on. Right? I need to be in that study, right? And so now you've got this person that's motivated toward your study for personal reasons, which again makes them not representative of the population. And also might skew the way in which they participate in your study because of that personal motivation. We also have exclusion bias, right? So we often set up these sort of barriers to participation or ways in which we're going to exclude people. One of the ones I always think about really commonly with college students is like, so we're doing research with college freshmen, for example, and the thing that we usually say is like college freshmen who are over 18 years of age. Well, why do we do that? We do that not for any theoretical reason or because we think there's something weird about college freshmen who are 17. We do it because we don't want to have to get parental consent. Like it's a legal and ethical thing because it's difficult to get parental consent, so we just don't do it. We just say if you're under 18, we're not going to include you in the study. But the fact is we wind up excluding this big piece of college freshmen that might actually have something valuable to contribute to this study. You know, you think the same thing about like, so we did research with rural American Indian families and a K-12 schooling system, and there were a lot of them that you just didn't ever get anything back from the parents. Like you would send home the note, right? We were looking for consent, and you would never get it. And it's like, well, no, so luckily we had a good research associate who would like go out to the community and like try to get people to sign, you know. But and in many studies, what you wind up finding is like, you send it home, if it doesn't come back, the student doesn't do the study, right? And you wind up excluding a lot of people either because like maybe the parent has a difficult time understanding what they're doing, they don't understand that it needs to come back, they don't get the purpose of the study, they're not particularly involved in the schooling, whatever it is, they're excluded on that basis. And in fact, that's a part of the population that we really want to understand what's going on with them. I'll give another example. I was just reviewing an article it was submitted for publication at a journal that I'm a reviewer for, and they collected all of their data at what they collected all their data at parent-teacher night. Not parent-teacher conferences, it was some other kind of parent night. And they said that roughly 30% of all the parents in the district attended. And I thought, well, so what about the 70% of the parents that don't attend parent night, right? Like those are parents who, of course, and they went on and on about how great it was, how, because it was a scale for like interest in their child's schooling, right? Of course, this is the group that scored high on that scale. They're at parent night, right? Well, you've got another 70% of the parents in the district who didn't show up to parent night and also were not surveyed because they didn't show up for parent night. You've got to find a way to reach people who aren't convenient to you, yet their data are going to give you something interesting, some other form of experience, right? Because they're the ones that are going to report low interest in schooling. Right? Obviously, they didn't go. Right? Either they're low interest or there's some other barrier to them being in school, like work. Right? Okay. So we also have issues with attrition, for example. So attrition can happen in a number of ways. Like, for example, if you have a longitudinal study, you need to get data from people at more than one time. A lot of times people just don't come back or they will not respond to you, things like that. And then you wind up without that person, right? Which biases the sample. The kind of person who drops out versus the kind of person who stays in. When we do online surveys, which online surveys have all kinds of problems, but one of the problems they have is that people have the opportunity to drop out in between pages, right? They click next, and then they see that little progress bar move, and they go, oh, I'm out of here, right? I've done that myself as a participant, right? I try to fill out surveys when people send them to me. Sometimes when I click next and I see it just go, right? It just barely moves. I click exit, right? Right, I just answered 100 questions and the 3%, I don't think so. I'm going to go ahead and exit, right? So people have that opportunity to leave the survey in between pages, and what you wind up with is this set of people that were willing to start a survey but were not willing to finish it, and so you can't include them in the results. So there are a lot of different ways that we can bias our results by the way that we structure the study, by the way that we structure our sampling methodology. So there are ways, I think, to minimize the bias, and so there are probably a lot that you can think about as you think about the particular type of research that you do. I think the biggest one is to lower the barrier to participation as much as possible, make it as easy for people to get into the study as you can. I think that online surveys have a lot of problems, so I don't necessarily think that that's a great way to accomplish this. So one of the things that I like to point out about like online surveys is the data are less reliable in online surveys and more variable and a lot more extreme usually. So you think about, like, have you ever read the comments on like a news article online? Have you ever done that? If you haven't, you probably should sometime just for entertainment value. So what you see there is like no one has any moderate opinion to share, right? It's very extreme, very, you're Hitler, yeah, well, you're Stalin, that kind of stuff. It's very, very, very extreme. And one of the reasons for that, we could explain in psychological terms, is like there's anonymity. When we have anonymity, we get more extreme, right? And an online survey, so in a face-to-face survey, there's there's anonymity, right? But at the same time, they are looking at you while they're filling it out, right? They're in the room with other people while they're filling it out. In an online survey, it's deep anonymity, right? No one will ever even know that they were, there's no way to ever even do anything. So the surveys, the responses get more extreme. The other thing that you run into is people just clicking their way through it at random, which happens a lot less. It does happen in person. It happens less in person. And if you're offering an incentive on an online survey, people will click their way through so they can do it multiple times or get multiple chances at whatever the incentive is. So the online surveys have some issues. You also have the issue of like an uncontrolled environment, right? So you don't know where they're doing it, what's going on around them, if they're talking to other people while they're doing it, which is a big problem. You don't want people doing that while they're taking a research instrument. So anyway, so I think there's problems with online surveys. Not that they can't be useful, they can. Just there's things to be wary of with them. And one of the things, so like this works, I think, with K-12 research or college student research, is to if you go at the beginning of a class, right? So people are often tempted to go at the end of a class. I think it's less disruptive. It's equally disruptive to go at the end of class than the beginning of a class, right? You're still taking 10 minutes or 15 minutes off of the lecture time. But at the beginning of a class, what you set up is a situation where the choice that a student has is either do a survey or wait. At the end of a class, you're setting a choice where the student either does a survey or gets out of class early, right? So it's a really different choice. Where what my experience has been is like around 95% of students fill out a survey at the beginning of class, and around 40% fill out a survey at the end of class. It's a big difference, right? So you get that sort of captive audience going on, and so even though there's still no coercive power, more will fill it out. And also eliminates the need for an incentive, right? The incentive is, you're here. Would you like to do it? No? Okay, so that's fine. Please be quiet, right? So, because there's a lot of like the incentives, the offering of an incentive, like I'll give you $1, or I'll give you $5, or interview you for a chance to win a mini iPad or whatever it is, right? So that kind of stuff can actually raise selection bias. And there's some research to support that. So getting away from situations where that's necessary. Because the problem is, like, if you put up a flyer in the hall, come do my study, there's no incentive. The response to that's not going to be great. So setting up a situation where it's not necessary is ideal. And of course, doing that without any sort of coercion. Yeah. Okay. So it's a little bit about selection. I do want to make a note about this issue of, because we're going to move away here a little bit from the idea of research design and start talking a little bit about methodology, is that we design studies to answer research questions, and then we're gonna select the statistical method to match up with our research design, right? So we might have a research question about the difference between men and women on math self-efficacy, or the relationship between math self-efficacy and likelihood to pursue a math major, right? And we're going to design a study that enables us to answer that kind of a question. Based on the type of research design that we set up, we're going to choose a statistic. A statistic that matches the research design, right? So here, this is a between groups question. This is probably like a t-test. This is these are both continuous variables. We're probably going to choose something like correlation or regression, right? So we're choosing a statistical method to match a research design. So we're going to start with a research question. We're going to design a study that will allow us to answer that question, and then we're going to choose a statistical method to match that research design. The order is important, because sometimes what people wind up getting tempted to do when they learn a statistic that they think is interesting or that they kind of are able to work with and understand is that they'll think, well, I ought to go back and design a study that can use this statistic. And that is a trap that's easy to fall into, and it leads to really bad research. It's question first, then design, then statistic. Statistic is last, right? We don't learn a cool statistic and try to find a question that we can answer it with. Okay, and so then of course some questions are going to be suited to qualitative inquiry. Not every question is a quant question. A lot of them are qual questions, but if it's a quant question, we use quant methods, right? And then some quant questions are between subjects, some are within subjects, so on. And I always like to add here a little bit about the idea of mixed methods. And so what people sometimes get tempted to do is to do like something like a mixed method dissertation or thesis, because they think that that's doing both qualitative and quantitative, and so you can get away with like doing both in one study or something like that. When really mixed methods is a third methodology that requires as a prerequisite a strong grasp of both qualitative and quantitative, and then you would learn a third methodology, called mixed methodology. So it's not doing both. It's not doing qual and then quant, just putting them together, right? It's a third thing. So anyway, if you're wanting to be able to demonstrate knowledge of both qual and quant, the way to do that is do qual studies and quant studies along the way here. academic career. And then do a dissertation or thesis in whatever you're strongest in. Okay, so that's my note there. We'll end up today talking about visual displays, and I have data. All right, so in the data that you have, which are made up, every student has gender, age, and GPA. So what we would do to begin to make visual displays of these data would be probably sort it somehow, right? And so I've sorted it two different ways. First, I've sorted it by age within gender, and then I sorted it by GPA within gender. And so what I mean by age within gender, it's like, so you've got gender, men, and then women. And then sorted by age, like 18, 20, 22, 25, 33. And then starting back with what we did sort by age within that. We could do it the other way as well. Sort by gender first, and then GPA within gender. Right, so here we're sorting GPA lowest to highest within each of the genders. Okay. And so we're not going to take time to try to sort by hand because it feels silly to sort by hand when there's a lot of ways to do that with a computer. You can do it in Word, you can do it in Excel, you can do it in SPSS, you can, I'm sure 100 other different programs will sort this kind of simple data. Okay, so instead what I want to spend the time talking about is like how we could make 3 of the popular visual displays data, just using the data that we have here. Okay, the ones that I want to talk about, I want to talk about frequency tables, histograms, frequency polygons, and then the stem and leaf diagram. So we'll start with frequency table. It's very simple. It's a table of frequencies. Right. So in other words, a table of how often each value occurs. So for gender, right, we would make a table and we would say, for example, there are men and women in the sample. Men and women. How often do they occur? The count for how often each occurs. And I don't actually remember the number, but so you know it might be like 8, 9, or something like that. I don't remember the actual number, but so we would just write the actual count for how often each occurs, which I don't recall this time. So that's all that a frequency table involves. Actual count of how often, or frequency of how often each value occurs in the data. So when it gets, I guess, slightly trickier is when we have a variable for which there's a lot of values, right? So you look at age here, and we have values starting at 18, and then I think the highest is 33. So to make a table doing 18 to 33, it'd be 15 rows, right? Which we could certainly do. Right? That's not crazy, but that's a lot of values. Right? And it would be more meaningful to look at if we somehow compress that into less rows. Right? So for example, we could go 18, 19, 20, 21, 21, 22, 22, 23. So compress it into 2 years at a time. We would then have a lot less rows to look at and be able to more meaningfully summarize the data. So for example, that's what I've done here. It's done 2 years at a time. You see we really quickly get the sense that, see 5, 4, 5, that you have 14 of the participants in the 18 to 23 range, and then only 5 participants total beyond that range. In other words, most of the participants in the traditional learner age, and then very few in the adult learner age. For GPA, again, if we did every possible value, we would start at 2.0, that's the lowest, And we would go all the way up to 4.0, which would be 20 possible values, right? Luckily, we only went up to 1 decimal, or it would like get a lot quicker. Right? So what we could do instead is find a way to compress that into less rows. And so the solution that I'll suggest, there's probably a lot of ways we could do it. One of the ways we could do it is to actually like line them up, right, and look for like natural breakpoints, you know, like every 5 or something like that. But what might make more sense is to think about, because with GPA, there are some logical breakpoints instead of natural points in the data to break it up. And for example, we could go 2.0 to 2.4 to 2.4, 2.5 to 2.9. So you're getting that like low C, high C, low B, high B, right? So you're breaking it up into those kind of ranges that I think a lot of people as academic professionals would sort of naturally think about. And so if we do that, we wind up with only 4 rows, really easy to think about. And we see we have this distribution that skews toward high GPA, so either grade inflation or this is a group of students that does very well. And so again, there's nothing complicated about making a frequency table. You just have to think about how to break up the data in ways that make sense. All right. And then once we have a frequency table, we're going to display those frequencies in some way that's meaningful. So this is where the histogram, frequency polygon, and stem and leaf plot are going to come in. For the histogram and frequency polygon, if you look on the back of your sheet, there's like some little grid paper squares that can be helpful for that. So a histogram is just a stacked bar graph, no space between the bars. And the height of the bar is equal to the frequency from the frequency table. Okay. So like you can see here in the top left example here, what we have is the frequencies for age from our frequency table. And so what we end up with is bars for each of the age groups that we set up. So like 18 to 19, there were 5. 20 to 21, there were 4. 22 to 23, there were 5. 23 to 24, no, 24 to 25, there were 3. Then we have 0, 1, 1, and 1. So it gives us an easy way to visually display where the data are distributed. And then the same for GPA. We have 2, 5, 7, and 2, 4, 5, and 7 in the 4 grade categories that we created. So you see that upward slope or sort of stair-step progression. Now, if I wanted to make a frequency polygon, what I would do is, and we'll see if I can do this successfully, I would make points on a graph where the tops of the bars would normally go. I know I'm not going to be able to do straight lines, but we'll see what we can get. We'll see what we can do here. All right. Okay. So we start at 0, we end up at 0, right? So starting at 0, we would draw a line. I told you I wouldn't be able to do this. Across these points, right? So it's the same points as the histogram, except for it's now a line graph. Okay, so that's a really poor drawing, but hopefully it gets the point across of what we're doing, right? So instead of a bar up to 5, it's now a point at 5. Right? So we wouldn't actually draw it over the bars, I'm just using it as an illustration. So what it'll actually look like is this. Starting at 0 and ending at 0. So that's why it's a polygon, because it actually makes a shape when you include the bottom line. The exact same information, right, but displayed slightly differently. Now it's a line graph instead of a bar graph. And I know what you're thinking, why would you do it this way instead of the other way? It's a really good question. The answer is because you wanted to. I know, see, you're looking at me like it's a bad answer. I don't know what else to tell you. Some people will do it this way. It's the real answer. So the histogram is like really a lot more common though. But every now and then you will see the frequency polygon. And just know it's the same thing as a histogram, but it's a line instead of a bar. Line graph instead of a bar graph. But line graph instead of bar graph, but also starts and ends at 0. Okay. And let's say you wanted to make a histogram or a frequency polygon. You could just do that in Word or Excel or PowerPoint or whatever. The trick to the histogram is you have to go into like the table or the graph properties and set the distance between the bars to 0. It's not a histogram with distance between the bars. Distance between the bars has to be 0. Okay, so then finally, let's talk about stem and leaf. This is an example of a stem and leaf graph for, stem and leaf plot rather, for the age and GPA. All right, so how does this work? Is we have the stems here, 1, 2, and 3, and then leaves here. So what's going on is that the stems are the first, in this case, the first number in the ages. So we have some people that are age start with 1, some people with 2, some people with 3. And then in ascending order, we're listing the next number in their age. So like there's 18, 18, 18, 19, 19. 20, 20, 20, 21, 22, 22, 23, 23, 24, 25, 28, and 31, and 33. Same thing is going on with GPA. I will not read them out loud because it starts to make me feel weird. Now, you're looking at this and I know you're starting to think, why would someone do this? This feels really weird. And the answer is on the next slide. So it becomes really useful when you have two groups like we have here, because you can put leaves for the two groups on each side of the stem. Right, so what we have here is the stem 1, 2, and 3, and then the leaf. So there's a man who's 18, a man who's 18, a woman who's 18, a woman who's 19, a woman who's 19. Right, man who's 20, man who's 20, man who's 22, man who's 25, man who's 28, woman who's 20, 21, 22, 23, 23, 24. Right, man who's 33, or I'm sorry, 33, and a man who's 31. So what we get is a really visual depiction of how those two groups separate in terms of this statistic, or this variable rather. Okay. And when this gets really interesting is when you see a clear, I guess, a break in the data on the variable. So like we might see that like all of the men are sort of up at the top of the variable and all of them are at the bottom, so you're seeing like the women are scoring higher, right? So it gives you a really visual depiction of how the two groups are sort of diverging from each other. So you just see people use this sometimes. If you want to make this type of a plot, like in really any format, I suggest the font Courier, and here's why. It's like if you use like Times New Roman. Times New Roman uses like half of a space for a lot of the characters because it looks nicer. Courier uses one space for every character, and so it means that everything lines up all pretty like this. It's a horrible font for like typing in, but like for this type of a thing, it works out really nicely because of that one space per character thing. All right. So I'm just have this.